Assalamualaikum. Good morning, everyone. My name is Farhan. Okay, we have 28 people now. Should we start or should we wait? What do you think? It's 10 a.m. already, but since we have quite less audience, I think we should probably wait a few minutes. Thank you. Assalamualaikum. Good morning. We have 37 people now. I think we can start. Okay. Welcome to Scce Research Knowledge Sharing Webinar Series number 12. This webinar is organized by School of Computer and Communication Engineering, Scce, Universiti Malaysia Perlis. For your information, this webinar can be watched at UniMAP TV and at YouTube, UniMAP Facebook, and also Scce Facebook. As this is the final series of research knowledge sharing webinar from SCE, I would like to invite the Dean of SCE, Associate Professor Dr. Azrani Abdullah Al-Hadi, for his welcoming speech. Please welcome.
Okay, Bismillahirrahmanirrahim. Can everyone hear me?
Yes, okay.
Okay, boleh ya. Okay, thank you very much. Thanks to Dr. Farhan for the MC today, and I'm not so sure how many of you registered for this last talk, but I really hope that you guys enroll and enjoy this very last session from the School of Computer Communication Engineering. I would like to thank to all the committees of the webinar of the school who, well, I would say, completely have done their good job and good task as our role of the school to deliver and to share knowledge. I think from the research committee side, I think they have organized around 12. This is number 12 webinar, isn't it? Betul, eh?
Yes, Doctor, number 12.
Number 12, the 12th webinar. And thank you very much for getting all the speakers, internal speakers, and also outside speakers. I would like to also say thanks on behalf of the school to the DMDC. I can see here Muhammad Afif and Cik Afif and others representative who has made this happen, to be shared in the Facebook, to be shared in the YouTube live. So thank you very much. I think Postmaster has overloaded information from us about the webinar. So we actually become the one who always share this webinar. So this will obviously be continued in the next coming weeks or months, where we will be combined with other school. I mean, probably some information for others viewers here. The School of Computer Communication Engineering will combine with the School of Microelectronics and one program from Mechatronics and also from the Faculty of Engineering Technology. So we will form into a new faculty called Faculty of Electronic Engineering Technology. So inside there, we have a lot of programs ranging from a diploma until postgraduate. So it will be exciting for this new faculty to see the direction. But nevertheless, the main point of having this faculty is to share the resources in terms of the lecturers, facilities, lab, and others. So I really hope that I can not 100% guarantee, but I can guarantee that this webinar will be continued, if not from the same committee members, but there will be a new members that will handle this webinar. So just keep in touch, stay tuned with the information that we will be sharing from the website and from the Facebook, for example. And last but not least, you can actually have a look at the recorded link. I think they will share this after the presentation, but we have one specific web page from the from our school website. So we have combined all those webinars, so you can obviously see the recorded lectures there, and then even you can also download from there. So we keep in touch. Stay safe, everybody. I cannot join until end of this session, but anyway, thank you very much for joining this. Join till the end, then you can get the certificate, ya. Betul, eh? Okay, don't sekejap saja, okay? Maintain till the end. Alright, so thank you very much. Terima kasih, MC. Assalamualaikum, and thanks again.
Thank you very much, Dr. Azali. Just like Dr. Azali said, among the reasons why this is the final webinar from SCE is because SCE will be no longer exist starting from tomorrow. So hopefully you look forward for future webinars from the Faculty of Electrical Engineering, inshallah. Okay, so we do it differently this time. I would like to invite all of you, since we have our dean here, we will do the photo session now for the speech, and later on we'll continue with the webinar. So can you switch on your camera for those who are ready? Okay, I ask for Dr. Noramina to click the picture. Any more? Dr. Noramina, can you come?
Yeah, okay. Okay, you ready? Okay, 1, 2, 3. Maybe one more time. Okay, hold on for a second. Okay, one more time. Okay. 1, 2, 3, smile. All right, thank you very much.
All right, thank you everyone. Okay, before we begin, I would like to make a few reminder. Please fill in the Google Form attendance form. The link is given in the chat room. And also later on, please fill in the evaluation form. The link will be given at the end of the session. So please stay until the end of the session, and the link will be given, and please fill in the evaluation form of this webinar. Another thing is, please, during presentation, please turn off your microphone. Before we start, I would like to introduce you to our honorable speaker. Associate Professor Dr. RUZELITA NGADIRAN received the Bachelor Degree of Engineering in Communication and Computer Engineering from Universiti Kebangsaan Malaysia in 2002 and Master of Science from the same university in 2007. She received her PhD degree in 2012 in Engineering of Communications and Signal Processing from the Newcastle University, Newcastle upon Tyne, UK. Currently, she is an associate professor with the School of Computer and Communication Engineering, Universiti Malaysia Perlis, Malaysia. Her research interests include wavelet transform, image and signal processing, digital watermarking, and artificial intelligence. So without further ado, please welcome Associate Professor Dr. RUZELITA for her presentation on image quality assessment and overview. Please welcome. Dr. RUZELITA, your mic is still off. Okay.
Sorry. um, okay, is that clear?
Yes, you can see it.
Okay, thank you, Dr. Nur Farhan, for the introduction. And I would like to thank you also, the Dean, for his welcoming speech, and the Research Committee of SCE for organizing this event, this webinar, and for giving me the opportunity to give this talk.
Dr. RUZELITA, sorry, I can see that your slides is not fully, yeah, now it's good. But it's not fully visible. It's like it's cropped on the right.
Wait. Ini okay?
No, it's like it's cropped. Dekat logo UniMAP, it's cropped there. Should be.
Ini okay?
Yeah. Okay, now it's good. But when you present it,
okay. When I this is the presentation, it is cropped,
it's
is it?
cropped. Yes, yes.
Oh,
But I guess maybe not very much information is being cropped. So do you want to proceed?
okay, is it okay if I share like this?
What does the participant think? Is it okay? Should we just open the crop version or this version? Anyone?
Mana-mana pun tak apa.
Boleh. So
Probably
Yeah,
Dr. Rizita can minimize the left border, the left column. You can minimize
make
it
it
with
bigger.
no.
No need to open the presentation, but just close the apa tu? The left
This
side,
one.
The left
thumbnail.
panel.
Okay.
You can
Sorry.
minimize close it.
Okay, is it okay now?
Yeah, I think it's okay.
Okay, thank you everybody for joining this session. Okay, so today's talk is on the image quality assessment. An overview which consists of related research, relevant application, and actually we are looking ideas or the challenge that we want to move forward for this research topic. Okay, so quality assessment is needed to ensure and improve the content delivered to end user. Usually the quality metric will be used as a criteria or optimization goals in the visual communication system. So first, let's have a look at the key phrases of digital image processing, where IQA play its role the most. So in every in today's lifestyle, right? Everybody have a smartphone. So in 2017, it is estimated that the number of digital images is around 1.2 trillion available. So that one is in 2017. By now, the number should be triple or double, because everybody have a smartphone and everybody is camera. So they usually upload the image on the media social, and then with this, a lot of image available. Image or media available. So with this come as well with the related application related to the image that is available. For example, we have image enhancement to improve the image restoration. In the case where the image is low in resolution, we can restore by applying a super resolution technique. Morphological image processing in the case where we want to removing the imperfection or get a straight line or improving the edges of the image. Image recognition in case where we want to extract information for image. For example, we want to extract segment the car image, or we want to extract the from the image. So we need image recognition, representation and description. Mostly used, also used in medical image, where they want to make sure the image taken is represented well with the actual image. And then for IQA, usually initially it is very important in transmission, visual communication system, where for image compression and decompression, usually we will have an original image, and then we will compare with the compressed or transmitted image. There are also a lot of research has been focusing on grayscale image to reduce the complexity, but in color image processing, they have different spectra, so different process related include. So IQA, actually we need to have IQA. As the first one, we need to design an effective computational model in order to automatically predict the quality of the image in perceptual consistent manner. In other words, we need to create a model that is very similar to how our eyes perceive the image. Okay, so there are two types of measurement. The first one is a subjective method, which is a human viewer perception about the attribute of an image or set of image. The second one is the objective method, which is based on the computational model that can predict the perceptual image quality. So as I said, we need subjective assessment to train and to test the objective IQA that we have developed, whether it is suitable or whether it is correlate with the subjective evaluation that have been taken into as a value. So for subjective evaluation, the measurement for subjective evaluation, it is using mean opinion score method. Is based on the value like this, which is very poor quality. For one, lowest value is very poor quality. The highest value for the excellent quality. And then mean opinion score will produce a precise and reliable end result with small score number. An amount of observer are chosen and analyzed for their visual capability. And then the observer will be shown a series of test scene and requested to score the scene quality. For this experimented or subjective evaluation, usually we have to follow the guideline by the IQR BT500, which involve the environment setup, subject recruit, grading, and the processing of the subjective evaluation. And to get the subjective evaluation is not cheap, so it is very expensive, time consuming because the observer have to spend some time to rate the image. Sometimes it's too convenient as human beings are involved in the evaluation. So many factors can as well affect the evaluation. For example, lighting of the environment setup, device quality, human emotion can also affecting the result. And sometimes we have a different aesthetic value based on the human personal point of view. The limitation is that the objective and subjective methods are necessarily consistent or accurate between each other. A human viewer might perceive a stark difference in quality in a set of image where a computer algorithm might not. So, but for this example, if you can see the image with the head colored head here, the difference between the left and right image is actually around 1 dB. But for me, as a human observer, I don't see much difference. For me, the quality is the same. But in terms of peak signal to the noise ratio, it is different in terms of 1 dB, which is quite a lot. The next image as well, we can see that the difference is around almost 2 dB. But because the image contains a lot of information, like the lot of leaf repetition here, it's also very difficult to see the difference between those two images. So if let's say we are as a subjective evaluation, I would give the score for this image is the same score. Okay, so let's have a look at the next image, which is consists of different distortion applied to the original image. So the left one is the original image, and you can see that different distortion applied to all this image. And as personal opinion, I would say like the worst one would be the wavelet distortion, because it have a lot of artifact behind the grass here, and then a lot of information is missing at the edges of the girls here. But the actual calculation peak signal to the noise ratio for all this image, this is total image, it's actually 22.5 dB, which is all the same. But for human being, we can see that some distortion, for example, luminance reduction doesn't have any different to the original image. So that's why end objective IQA need to the mathematical modeling need to mesh well with this type of conceptual information. Okay, so the next one that we need to look at is the availability of the data set. So the data set available for the analysis of or the development of the IQA, the traditional one is based on the distortion-based data set. The most popular one is this 6 data set. The first one is live data set from the University of Texas. 10-pair image data set. They have two different years, 2008 and 2003. And then CSIQ, IVC, and MICT. Most of the data set have original reference image, for example, around 30 reference image, and then they apply a distortion. For example, for live data set, they apply 5 types of distortion, and then the total number of the image in the end is around 779 with only 5 types of distortion. And then the ground truth, the subjective evaluation apply is the differential mean opinion score. For ID 2008 and TID 2003, the ground truth is mean opinion score applied by the subjective, by the human viewer. So all the traditional data set, it has been very popular, being used as an assessment for the IQA. And then they have some recent data set, for example, Waterloo Exploration data set, which is created in 2017. It have a lot of images, which is around 4,000 images. Unfortunately, it doesn't come with the ground truth of human subjective evaluation, because maybe the image is too many. It is very difficult to get a human observer to rate the image. And then another one we have in 2018, which is IQA Expert 300, which been the image is actually from Flickr, and then it's been annotated by the expert photographer, hence the name is IQA Expert, and then it has around 200 images and been evaluated by the human observer. Okay, so most of the data set is based on the 2D image. It can be color or grayscale image. But now we have emerging data set which is not limited to distortion data set. We have a 3D image data set, screen content image, tone mapping, which is referring to HDR image, dehazing, image that contain the haze environment, and the other one, the final one is virtual reality data set. So with a new data set, of course, we need to think about what type of IQA assessment that can be applied of this new type of data set. So this one is the example data set from the IQA Expert. They provide screen expert crowd workers in the IQA assessment, and then this is the example of the image available in that data set. So from the data set, now we can create all the IQA values because we have a reference from the mean opinion score. So all these IQA actually, where is this applied on? Okay, now with the popularity of stream-based movies or videos, Netflix itself has developed an IQA assessment. The IQA assessment is based on video multi-method assessment fusion, which is a combination of IQA method combined with support vector machine. Two of the IQA method that been used by the NEFLIC is the visual information fidelity, which is well adapted in IQA based on the premise that quality is complementary to the measure of information fidelity loss. The second one is detail loss metric, which is based on the rationale of separately measuring the loss of detail, which affect the content visibility, and the redundant impairment, which distract the viewer attention. So for the first one, actually, visual information fidelity is implemented in the Wavelet domain. Okay, so all these data set and this application. So now we look at the method available for the IQA assessment. So this is taken from, the classification is taken from Xci 2020, which is a recent review on the IQA assessment. The IQA usually are divided into three main techniques. The first one is the full reference IQA, which is referring to the availability of the original image. And the second one is the reduced reference IQA. Usually is popular for the transmission process, where it's aimed to reduce the complexity, the need for having a full reference image at the transmitted destination. And the last one is non-reference IQA, which are getting more and more popular since we have a deep learning algorithm right now. So non-reference IQA are becoming popular because it is more practical, since we don't have the original image to be referred to. So we will look at all these type of classification. And then for the research that we do is actually based on the full reference IQA, and then it is classified in two different domains, which is spatial based, which is based on the pixel based algorithm. We compare based on the pixel, and then there are three types which is quite popular right now. The first one is signal fidelity based, for example the DLM just now, and then spatial based, which is structural similarity based. The most popular for this this category is SSIM, Structural Similarity Index, that has been developed in 2002. And then a last one which getting more popular today is the learning based algorithm. Okay, so spatial based, basically it is directly from the pixel of the image. And then we have also transform based, where the image is transformed into a different domain, usually a frequency domain, or cosine domain. And then we do, because the aim is that we need to find the difference between the original image and the distorted image. So the difference have to match with the perceptual human viewer. So in transform domain, in the frequency domain, it is more relevant to the human perception. So most popular one is Wavelet domain based and DCT domain based for this full reference, and a lot of technique have been developed and for this category. The second one is the reduced reference IQA, also divided into two categories, spatial and transform based domain. And last one is the non-reference IQA, which is categorized into two types as well, distortion specific and general purpose. So for distortion specific, we analyze the IQA based on their distortion type. For example, JPEG have been used for a long time, but it is known that it have give the blockiness effect. So so they studied the blockiness effect, and then it is easier to understand the blockiness effect based on the DCT domain. So once they found out this blockiness effect in the image, they can consider it this is the quality is not very good, something like that. So, and then blurring or noise, usually because we have lost the edges, for example, in the hazing image, we don't see the edges of the building. They try to understand the absence of the edges in the blur or noise image. JPEG 2000 is referring to the wavelet compression, which usually affecting to the ringing artifact in the image. For example, like this image. So JPEG 2000 and wavelet distortion is where we can see that they have all these ringing artifact inside the image. And JPEG, you can see that this is the blockiness. So to understand specific domain of the distortion, it is easier to come up with the quality measurement based on the specific distortion. For general purpose, usually it is based on training, and it have three different category, which is NSS based, which is based on natural scene statistic of the image. Learning based, for example, the deep learning or CNN, something like that. And then last one is the HVS based, which is consists of transform domain and and learning based as well. So let's go to the first category, which is full reference IQA. For this category, it's been researched for since 2002. So there's a lot of research under full reference IQA. So the key idea is that we find a difference between the reference image and the distorted image. So the first step, this is the general process. The first step is we need to find the local quality or distortion measurement. So this one is based on a certain kernel or size of the reference and distorted image. We find for each the different for each area. And then after that, after we find all the distortion value, we need one value pooling approach to sum up the quality score. Okay, and then the second image here show that, for example, this is due to the blurring effect. So we have reference image and the distorted image. We can model by using a perception model to match the human viewer, and then we decompose it because this is color image. We decompose into visual channel or color channel that are available from the image. This is the modeling. We need to find the measure of difference, and the weight summation is the pooling approach before it come up with the quality score. The next one is Wavelet IQA. This is actually the work that has been applied by my student. When we have an original and distorted image, we apply preprocessing. Usually refer to we reduce the color image into one domain, which is the grayscale domain only, and then we apply channel decomposition for or wavelet transform to the original and distorted image, and then we will find the error in each subband, and then error masking process is applied before we go into error summation or weight sum of the to get the quality or distortion measure. Next one is the reduced reference IQA. This is the basic model, the basic framework for the reduced reference IQA. As I said, reduced reference IQA is usually is focusing on transmission domain to transmit the image. So for the framework for reduce IQA, the aim is that we want to reduce the need of original image at the receiving domain, receiving part. Okay. So there are usually three um, uh, uh, we need to have features from the original image extracted from the image, and then some method are embedding a digital watermarking into the image, so they can only take they only need to take the watermarking value at the for a comparison of the quality. And then some of the method are applying statistical algorithm in Wavelet domain to get the features from the original image. So we have, let's say we transfer the image, and then the distorted image will be taken, the feature of the distorted image will be taken as well, to be comparison from the feature extracted from the original image at the receiving end. So this come with the quality score. So compare with the full reference and reduce reference. Reduce reference aim to reduce the complexity of the calculation of the quality score. And the last one is the non-reference image quality assessment. For this method, usually the framework is based on the learning method. We have natural image and the distorted image means the original image. This is for training. Usually we will base on the data set as well. We taken the features extraction from the image to do the training, and then same method of extraction feature from the distorted image. We compare. We compare with the we come up with the quality prediction or the quality score. So for this method, it is very suitable in a case where we have too many image available for evaluation, and it sometimes is not suitable for us to get a human evaluation for the image. For example, we have too many. Simple example, like we have taken too many image in our smartphone, and when we want to delete it, of course we prefer the one with have a lot of blur in the image. So non-reference IQA will be the best method to reduce the image in our smartphone, for example. However, non-reference IQA is challenging, but it is very attractive for many applications, since in today's we have a lot of image available. For the specific distortion type, we will focus on the analysis of each distortion. For example, I mentioned just now, JPEG 2000, blurring, they have reduced in certain domain, no edges at the certain domain. So other method which is available as well, we have a learning-based method, which consists of supervised and unsupervised technique. Okay, other method that is available for this NRIQA is past representation to extract the Wavelet domain feature and apply into a learning algorithm. K-nearest neighbor apply in a popular algorithm like Divine, rank learning, and now in 2019 a lot of work has been implemented for the deep learning algorithm and convolution neural network algorithm. So when we have all these technique applied, so we need to measure the performance of the proposed IQA. Usually we will base on the statistical analysis, and the popular metric are root mean square error, Spearman rank correlation coefficient, Pearson linear correlation coefficient, and Kendall rank order correlation coefficient. So this is an example of scatter plot based on the root mean square error. And then this is the work that have been done by my student. And then the scatter plot, we will want to find the scatter plot that is very correlated to the mean opinion score from the human observer. So this is IQA values and a plot as well with the mean opinion score. So from this, we can see that PSNR, it is not very much correlated. SSIM start correlated, but there's still a lot of distribution in this area. And then SSIM is improved by MS SSIM. WSSI is referring to the wavelet-based algorithm. This is some other method that is in the full reference IQA as well. So my student do this implementation in the wavelet domain with combined with the SSIM method. So of course, it's come with the trade-off of higher complexity, but also at the good statistical correlation with the mean opinion score provided by the human observer. So some might ask, because in today's we have a lot of good quality camera, we have a lot of storage available in our phone. Why do we still need the IQA? There is still room to improve the accuracy of IQA. For example, the highest value for the IQA is usually the statistical value is around 0.95, 0.96. So there is still room to improve. And then with the implementation of deep learning or learning-based algorithm, sometimes the value might not go very close to 0.98, something like that. So there's still room to improve the accuracy of IQA. But at the same time, we want to look at how to reduce the complexity of the algorithm. So by reducing the complexity, we can improve the speed of calculating the IQA values. And then we need to find new ideas for the extend dimensionality, for example, in stereoscopic image, HDR image, virtual reality image, and the image which come with multiple distortion. For example, not just blurring, but it's combined with blurring and compression distortion. And lastly, perceptual optimization means the qualitative of experience is one of the new keyword for the research area within this IQA domain, because it optimized based on the perceptual values and based on the quality of experience at looking at the media that we have. Okay, so this is the reference that I've been used. To be honest, I'm go quite general on this talk. So if you have any question, so for this topic, you can ask me now. Okay.
Thank you very much, Dr. RUZELITA, for a very interesting presentation. So I open the floor for question and answer session. Do you have questions? Any questions? Okay, Dr. RUZELITA, can I start with mine?
Okay.
I have one. Okay, we know that we have a different image format, like as we always said, the TIFF, JPEG, PNG, all those formats, right? So in what call it? In image quality assessment, is the algorithm to assess the image is different based on the format of the image? Are different image format requires a different algorithm to be assessed?
For different image format, actually we don't need different IQA. It's just that because different image format actually representing different compressions, so it's still in the domain of compressed image. So for example, in JPEG and PNG is actually a lossless compression, but it comes with a higher image size. But for JPEG, it is a lossy compression. So of course, the image, the IQA assessment for lossy compression will have degrading quality. So there's no need to have a different IQA for the different type of image, compressed image, as long as it's still within the same domain. For example, it's in the compressed domain. I hope is that answering your question.
All right, thank you, Rita. So we have a few questions here in the chat room. Do you want to see it, or do you need me to read it for you?
Okay, I can read it. From your experience, what is the best IQA metric that can be used for denoising segmentation of vessel-like structure in optical image? Okay. Vessel-like structure. Okay. Because if segmentation of vessel-like structure, usually the algorithm is based on edges, right? Who's the question? Muhammad Anwar. Okay, so usually for when we compare it with edges, so structure-based IQA is definitely a way to be used. So there's a lot of structure-based IQA available. The basic one, of course, the SSIM. But the variant from the SSIM is, there are many variants from the SSIM IQA. Okay, I hope that answering question. And then what is the correct flow or stage of segmentation of an image with minimal loss of information, the original image? For example, we do resize the image first for faster computation, before segmentation, or afterward, then proceed with the diagram. Since I believe some information might be lost during resizing of an image due to compression. So with the minimal loss of information, actually, there is no problem to apply the segmentation, since the aim is that we want to segment the image. We want to know what is the object is, for example. So IQA is not necessary. It's not necessary unless the information have been a lot lost. So if we want to embed, for example, we can embed before the before we apply into the segmentation algorithm for the IQA, but it's not necessary. I mean, like that is my personal opinion. What is the most difficult type of image to be accessed? I think now we have a lot of it is actually quite easy to have image with distortion, and we can say that the image is low in quality. But for example, image with enhanced with contrast enhancement, for example, it doesn't have much changes. So to say that what is difficult type of image to be accessed, maybe we can look at a new different type of media of images. For example, when we have a stereoscopic image, there are consists of two similar image as a different rotation, right? Rotated differently for left and right eye. So how we want to assess, let's say only one image been distorted. So how we want to assess that? So I think the best answer for this question, most difficult type of image to be assessed, is the new type of media that we have. For example, virtual reality. How do we want to assess that? Because for the 2D image, there's been a lot of research for the IQA assessment. And last one, I hope, sometimes image enhancement may change the way it's look, and it may appear to be artificial. for medical image, it could be dangerous because it may change color and specimen. What is your suggestion to maintain a good quality image at the same time not changing the image too much? My suggestion to maintain a good quality image. Okay, for medical image, it is very quickly to do processing. But we need to do, for example, to detect the first question just now, to detect the blood vessel detection. And then usually for this type of image morphological is applied to the image morphological processing is applied to the medical image. What I would say is that for image enhancement, as long as we didn't change the because for me, structure play an important role in the image. So as long as we didn't change the main structure of the image, we change the contrast for luminance domain, I think should be okay. As long as we may get the information that we want to get from the image itself. I do hope it answered Dr. Rafika's question. Okay.
All right. Okay. Thank you, Dr. Rafika, and thank you everyone for the question. Can I please? I would like to check. Is there a question in Facebook? Dr. Nura, can you confirm? Is there any question from Facebook?
No question from the Facebook.
No question from Facebook. Okay. Is there any more question from the Google Meet audience?
Okay. So thank you. I would like to thank you everybody for joining this session. I hope this little knowledge will your interest into this topic of image quality assessment. That's all from me. Thank you for joining.
Thank you very much.
I pass back to
Dr.
Dr. Farhan.
Thank you. Thank you so much, Dr. RUZELITA, for a very interesting presentation and Q&A session. I hope with the questions that has been asked, I think it helps us to understand more on this topic of research. Okay, before we end, I would like to remind again, please fill in the attendance and evaluation form that has been put the link on the chat room. So please check there. You need to kindly fill in the attendance form and also the evaluation form, 2 forms, yeah. And as this is the final series of research knowledge sharing webinar from SCE, on behalf of the research committee and SCE, I would like to take this opportunity to thank all participants for your continued support and participation in all webinar series. We are on the number 12 now, so we have 12 webinar series already. We sincerely apologize for any inconvenience caused, and we hope that you find all the webinars informative and valuable. So thank you very much, everyone. We'll end the session here. Thank you so much for your participation. Assalamualaikum.
Waalaikumsalam. Thanks.